welcome to Desk Ladyada.
Hey everybody, welcome to Desk Ladyada, brought to you by Clorox Disinfecting Wipes, which I'll put away now.
Yeah.
I clean my desk. So we got an exciting half an hour of some goodies from my desk. It's me, Ladyada. This is my desk. It's just chock full of electronics. Got some Trinkies to show off, some designs. We got a great search at the end. But I thought we would kick it off with a preview of a new feature that's coming to Learn, or it is at Learn, and you can check out. It's called Bundlefly.
Yeah, that's right. So I'm going to go to the computer.
Yeah. And
we're still working on this, so please try it out and then let us know how it works. But basically, and Ladyada will talk about this in a minute, all the things on how it works. We'll have a fun little helper. Right now it's Project Bundler, Project Bundle, Project Bundling. We say Project Zip right now because it's the old way we used to refer to it. But we'll have a little character called Bundlefly. And
so cute!
And Bundlefly will help you out. You know, no one's ever heard of insect politics. And so Bundlefly will be the little helper that will bundle it up for you and fly it off to you. That's Bundlefly. So, Ladyada, what exactly does this do?
Okay. What is this nightmare? Okay, so... you love CircuitPython. CircuitPython is so easy to write code for and adapt and modify. It's really fast to develop.
I've been told it's too easy.
Too easy. But there's one thing that is, it's a little annoying, is dealing with all the libraries. Because here at Adafruit, we're computer scientists, and with MIT, we're computer scientists, and we believe in this computer science concept of dividing up your code into small modules that you can then reuse code as much as possible and share it among, all of our drivers, all of our board definition, board support packages, etc. So we have one library just for NeoPixels, and we have one library for NeoPixel animations, and we have one library for every sensor. We have a library for touchscreens, and we have a library for dealing with I2C devices and SPI devices. Each one has its own library, which means you only import the things you need. But then, when you end up with a complex project like this touch deck, right, which is an RP2040 display touchscreen, so you've got, libraries for the touchscreen, for the display, for the buttons, for the icons, for loading bitmaps, et cetera, and, for stuff like Arduino, you use the library manager in Arduino, and you install the libraries once, and then they're linked and compiled in so that you have one firmware file. But with interpreted languages, it doesn't quite work like that. Yes, we could, in theory, make one, CircuitPython build that has all the libraries built in for every project, but that would be kind of overkill and complicated. Instead, we use the file system, and we have all the files in the file system. But that means that every time you build the project, you have to go to the bundle and extract the files and the MPYs, put them in. And I hear you, it is a little annoying. I just do it kind of in the back of my consciousness while I'm zoning out. But if you're starting out, it's why do I need all these files? And then, you drag one on, and then it's there's a dependency. And it's and you didn't even read the dependency because it's it's inside the library. So the Project Bundler solves this problem from within Learn by automatically giving you a bundle for the embedded code in a project that includes every library and every library dependency. So let's check it out. So this is the project code. So this code here is actually lives on GitHub, right? This is actually embedded inside, and we do that so we can have one place where code lives, and it's a place where we can do continuous integration, and we can quickly grep through every example if we there's a change or a bug that we copy and pasted a lot of. If the code lived in Learn, there would be no way to automatically check it, right? So the code itself. If you click on code.py, if you go to the bottom of this very, very long thing, no, it's not here. Sorry, it's under, oh no, we changed it. Or maybe it isn't under Learn. No, it is under Learn. Sorry, it's under GitHub, but I don't know why. Anyways, I'll figure that out. I think we changed this, but this code's in GitHub anyways. So to download the entire bundle, click download project zip, and we're going to change this to say project bundle. It'll be a nice big button. And then when you click that, the web server will create a zip file for you. And inside the zip file is the code and like anything that went in with it. In this case, it comes with also a bunch of bitmap images, like, for every icon and everything. And then it also includes all the libraries. And so you can see there's a lot of libraries. And it does this by, there's actually a little tool that can search a Python script and find all the imports, which is like a little bit better than grep maybe, but maybe not. Like you basically grep for the imports. And then you're like, okay, well that will give you, the libraries, but then they all have dependencies. How do you figure out what the dependency tree is? Because, when you include, trying to think like Adafruit Featherwing. Adafruit Featherwing actually has a bunch of other dependencies. It depends on the ILI 9341 library, and maybe it depends on the touchscreen library. There's like a lot of libraries that are hidden here. They're not literally shown here, but they're in the dependency tree of these libraries. So that project is called the Dynamic Bundler. It's actually a couple things. So let's actually just back up. So for every library we have, there is a requirements.txt. And the requirements.txt, it's always there, and it always has all the dependencies for the library. So in this case, it's Blinka Display IO and bitmap font. Every library makes, the person makes a library, they put in all the dependencies, and then what's nice is if you use pip on like a Raspberry Pi or Windows computer, you'll get all the dependencies automatically because this is a standard Python thing. Like this was invented in 2005 or something. The people are used to requirements.txt. So then we have in our bundle, which is done every night, which looks for all the new CircuitPython libraries that have been released, we have a new file called the JSON file. And the JSON file is like what it sounds like. It's a gigantic JSON file with, and I'm not going to, I guess I could open this up in a JSON parser. Basically, it's every library and every dependency that is on it. So for every library, it's like this is the first library, and it says, is it a package? What's the PyPI name? What's the version? What's the repo? And then it'll also say what all the dependencies are. So this depends on bus device, for example. And so instead of having to go to every single repo and ask it for the requirements.txt, this basically takes all the requirements.txt and sort of flattens it into one JSON file. And we'll have this also for the contributor bundle as well. But this runs every night. And then if you want to basically get the same thing but without the back end, I don't think the back end literally uses this code. I think the code for the back end of Learn is in Rails. And so it's not using this JavaScript. But if you want to implement this on your own or use this on your own, you can use the this example. So if you click on the dynamic bundler URLs down here, it'll automatically in JavaScript create you a similar zip file with all the libraries and all the dependencies in them. So basically, this is the start of having IDE support for managing our libraries and automatically installing all the dependencies. And this is something that we've thought about from the minute we first wrote libraries, because having lived through Arduino libraries and it took many, many years for there to be a library manager, and it wasn't until last year that there was a dependency manager. We wanted to make sure that was all ready to go. So when we wrote this code to do the bundling and the JSON and the dependency mapping, we would have all the data there. We wouldn't have to go back and maintain it. So we're kind of taking advantage of the existing Python dependency system that uses request.txt. We're basically caching that data once a night so that Learn doesn't have to hit all 400 libraries to ask each one of them and then do a depth first search for every single dependency. So if you want to check out that JSON file, you can then use it. And then we're going to probably have IDE plugins for VS Code and Atom and all those that can look at your code and say, hey, you're importing something, you need to install that. I'll get it for you because I've got that JSON file that tells me all the dependencies.
All right. Well, first up, before I talk about a couple things, thanks, Greg, for donating $4.99.
Yay, $4.99!
That helps fund some server time. So one of the things...
It's one Happy Meal.
So pre-COVID last year, I was a CircuitPython power user, and I built a lot of projects. I did a lot of things, found a lot of bugs, fixed a lot of bugs, did all these things that were really important. I don't get as much time now because I've been running Adafruit in a financial and global health pandemic.
Yeah.
So one of the things I used to do, and I think what you have to do is like look at folks, what they do when they're in a hurry or they don't have a lot of time because they get very efficient. I would freeze my projects. I would take all the files off my CircuitPython drive.
Yeah.
And I would move them to a folder on my computer, and I would zip them. Or I would just call them, the time, date, and the whatever it is, and it would have code.py, all the libraries and all the dependencies. And I knew if I had to in the future, I would just zap my CircuitPython device, and I would just toss it back on there, and those are all the working project files. That's really neat. So there's two things I suggest. So one, always make sure you get the latest version of CircuitPython. Double-click your CircuitPy, drag the new UF2 over, and then go to the project bundle and use our friend Bundlefly. Bundlefly will eat all of it, digest it, and then drop it in your browser. And
just like that.
Just like that. And you'll start. You won't have to do what I was doing, which is keeping all of your projects in an archive.
Yeah.
Because they already are. And if you look at what a lot of people do, they want to do a project, and then they start to mess around with some code. So you can easily get all of your project. Before it was just drag these things. That was easy, perhaps too easy, according to some. And then now it's even easier, which is you just get a chunk of files and then drag them over, and you're set. So
yeah, and having it all in one zip. And another nice thing is that when we update lots of libraries, instead of having to go back and update each one, first off, you could use the IDE plugins that we'll eventually develop, or you can just go back to the Learn Guide, click download zip, and it'll download whatever is the latest, right? You'll always get the latest. Because we also saw people, sometimes they'd have their libraries desynced. Like they'd update some but not the others, and there'd be enough change that we would have, one would be updated, one wouldn't be, and it would have a desynchronization and data expectation. So this way, every night the bundle gets created by Adabot, the JSON gets created, with all the version numbers, and then when you start up your IDE, it'll download that JSON file and it'll check. Also, by the way, every MPY file has a version inside of it that's automatically generated on the release tag of the library itself. And we worked really hard on this 2-3 years ago to make sure that in the future, if we had an MPY file, you can ask it what version is it, and you can figure that out by doing some funky searching stuff, or you can load it and query it. So the goal is to make it automatic library management from within whatever IDE or from Learn, either way.
Okay. Do you see this as augmenting CircUp or a replacement?
I think CircUp is going to be the command line version of this, and it's absolutely still going to be supported and used because there's some people who just really want to do it from the command line. But it will probably end up using this JSON if it doesn't already. I think we've done some PRs to it recently. Yeah. If it doesn't use this JSON already, it should, because it'll really speed things up quite a bit.
All right, so try this out now.
That's basically the same code.
Try it out now. Break it. Do everything, because we're going to be adding this to all the IDEs. And then if you're someone who's been in electronics for a long time, you're going to say, boy, this is saving me so much time. It's so easy. And if there's someone who's coming into this new, they're not going to get frustrated by all the things you need to do with all computers and all downloads and all IDEs and all code and all libraries and all dependencies. I think we solved a really big problem, especially for the people that don't even know that this is solvable yet. They haven't even got to man, this is hard. They're not even starting their journey. But now when they want to do a project, they can just hit up Bundlefly. Okay, what's next?
Okay, so that's Bundlefly. Thank you, Bundlefly, for your helpful thingies. So yeah, this is just, I want to show really fast. Can you go to the computer? This is the back end URL. So this is when I edit code. So this is where the code actually lives from. The code.py file. So, we have to, the goal though is to make it so people just have code, they don't have to know what the dependencies are. As long as the code works for them, we'll generate that dependency tree. So, cool stuff. Okay, next up, it's Trinkey time. So we have the Neo Trinkey guide went live. There's more to come with it, but we have at least the beginning of the Neo Trinkey guide. People are digging the Neo Trinkey. And so I thought we would, from learning from the Neo Trinkey, I've learned a couple things. We designed a couple more Trinkeys, and I thought I'd show them off on the overhead, and I can also do little demos for each one. So maybe I'll show them all off, and then I'll do a demo for each.
Okay. So do you want to talk about the little characters? You want to do that afterwards?
Let's show these off, and then you can show the characters because it'll be matchy. Okay, so this one is neokey Trinkey. I'm getting really close because these are pretty small. Okay, great. So this is neokey. So neokey Trinkey, as you might expect, is a mechanical key that you can put in any MX compatible key. It has a capacitive touchpad and a little NeoPixel that goes through and can light it up. This actually works, but the only thing I did is I moved it 180 because the LED was a little bright out here, so I made it so it's like when you plug it in, it's kind of glowing from the USB port sort of itself. So it's the Neo key. Then I also have the Rotary Trinky, which is, I think we've shown on a previous desk of Ladyada. So it's one rotary encoder that has also a clicky switch. So this, it can be used. All these are CircuitPython or Arduino. It's all SAMD21 on the bottom, and it's just like nothing is going to be that small and have USB and broad support. Like for something this tiny, it does a pretty good job of being, small as small as the rotary encoder. So I didn't want something big. I wanted these to be cute. We made slide Trinkey. We weren't sure this was going to work out because, if you pull it, is it going to yank out of the USB port? But turns out it doesn't actually. When you pull it, even if you're kind of being a little rough, you have to really yank at it to pull it out. That said, it's best if you hold on to it. But I think that there's still value in something like this. And you can see there's two reverse mount LEDs as well for glowing the slide potentiometer. And then there's proximity Trinkey. So proximity Trinkey uses a APDS 9960, which is this sensor here. It's actually a couple things. It's an IR proximity sensor. It's also a light sensor and a color sensor, and also does gestures. Although I'm always disappointed by the gesture sensing capability. There's also two capacitive touch and then two NeoPixels. And this was actually inspired. I was thinking about this. I remembered that Kano a long time ago made this motion sensor. So I thought I'd show this off. So this is from Kano. I believe that this is a discontinued part because I actually got this sort of on a clearance site for $10.
Yeah,
it's a really good deal, by the way.
I'll do a quick, back in the day when I would try to be a maker journalist, I would write about maker startups. So Kano, they are a UK startup. I think they were up to 40 million in funding, and I remember that because it was about the same as Little Bits at the time, and they were doing Raspberry Pi and/or single board computing kid laptops essentially, and they have since done some brand stuff with Disney. I think there was a Star Wars thing, and then we saw the Pi stuff and some of the Star Wars stuff on sale at Target, and then they pivoted, I guess, to more non-Raspberry Pi laptop computers for kids.
Yeah, I think they're doing x86 now, right?
Yeah.
Yeah.
And then their blog recently.
I really love their camera. We stocked their little camera, and it's great. This thing is so cool.
And so I also saw on their blog they were talking about blockchain and NFTs and all sorts of stuff. So I think as a startup, they have the ability to work on some of these things, even if they discontinue it. They have cushion where it's here's a proximity thing or here's a camera thing, and whether it's something that is going to be part of the core product line or some of the past products, they can continue to do product development. Eventually they got to probably...
They've got great product design. I mean, this camera, by the way, we sell hundreds of these cameras. These are really great.
They have retail packaging and all that stuff. So anyways,
hold on.
We saw this camera. We stopped in the store because it was a really good camera. And then we wanted to play around with this proximity sensor because we have a proximity Trinkey. Yeah,
so I actually got one of these, and it came in. So they have like really nice packaging. So this is like magnetic. It's got the little like magnetic-y flap. And then, they've got like this like huge like manual where they, it's like really beautiful art. Hold on. That they go through like how this works, and then it like snaps in. So it's like, they've got projects that are built into their system. So you can pick these up if you search for the Kano Motion Sensor. You'll see you can pick it up for like $12. It's a great deal for $12. I think originally it was more. And then it also comes with like stickers and stuff. So this is pretty neat. And I'll actually show you the output. But basically it comes with, so this is just a USB extension cord. Hold on. And this is like wound around the foam. This is kind of intense. So let me put this away.
I'm going to throw in some questions.
Yeah, tell some questions. So this is a USB cable.
One is related, one's not. Are we going to have a reverse mount NeoPixels in the Adafruit store?
Yeah, they haven't come in yet. I don't know why they're taking so long.
How about an IR Trinkey, both transmit and receive, plus touchpads?
I tried to make an IR Trinkey a long time ago, the PIR key, and like it was always such a nightmare. Like it never really worked very well. So I might look again at it, as part of this. But on the SAMD21, it was such a challenge to get it to, like the IR library was so big. Maybe I could do it with an RP2040.
New chips?
Yeah,
new chips. Time to revisit.
New revisit. So this is a little suction cup thingy, and then you can attach this extender to it.
Maybe that's Lego compatible?
I don't know. I don't think so. It looks a little bit too wide for Lego. So, but then you can. This is kind of cute. You suction this here. So this is the thing. Actually, so I took it apart. Just it doesn't normally come like in 3 pieces.
Yeah,
but obviously I wanted to take it apart to show you guys.
Yeah, it does a neat thing. Ladyada will talk about this, and we're probably going to use this idea.
Yeah.
She'll show you the way it spits out data.
Yeah. Cool. So this is, if you pop it, like this thing is this doesn't really do anything, I don't think. So this is just a little protector, and I pulled it off. I also kind of cut this down the side. I didn't realize that was not essential. Like you just pull this off instead. So you've got your SWD pads here. It's a very classic 2x5. Here is your APDS 9960. It looks just like an APDS 9960. That's how I know what it is. I've seen this many, many times, the sensor. And then underneath here, if you pull this up, it's a, they use my favorite AP2212 regulator, which is totally overkill. So they probably used it because I use it. And then here is an at SAMD21E16. So this is running Arduino code. I know it's running Arduino code because the VID is Arduino, so they didn't change it. So they either used, they may have used the Trinkey core, or they might have, created their own core. I don't know, but there's a SAMD21E18. It's inexpensive, so it makes sense, and then connected to APDS 9960 over I2C, and then I can plug this into my computer. I've got a non-Kano extender. Let me see, even though I broke it a little bit. So you can actually see this camera. You can see the infrared transmitter. That thing light up. So then, if you let's go to the computer, and I can show what it looks like. So on the other side, you get this, which is, it's JSON data. Well, hold on. I can't zoom in, but you'll believe me. So this is JSON data coming out. Hold on, there's too many ports. 1 second. Let me unplug this and replug it. Okay, great. So it spits up JSON data, and as I move my hand, it's it sends it out. Interesting, when you get close, it stops sending data. I don't know why. But, yeah, proximity data, and it's JSON formatted. I'm assuming that it also can receive JSON commands because you have to change the APDS if you want to put it into gesture mode or light set. Like the modes have to be set. Like it's default proximity, but you have to tell it what mode you want it to be in. So it probably has some JSON commands that it can take. So that's kind of interesting. So it's good. I'll probably use this kind of formatting because actually I'd rather like it. It's simple to parse. You could parse an Arduino with Arduino JSON.
We do everything in JSON now, so we may as well.
Yeah, and even in CircuitPython, even if you don't have the JSON library, this is a very easy string to parse. You could even eval it. Even that's a bad idea. You could.
Okay.
I think it would evaluate as a dictionary.
So those all the Trinkies?
So that's the Trinkies. So you decided to work with Bruce to come up with some cool graphics for him.
So each one's going to have a little character that goes along with it. This is going to be the Neo Trinky. And we'll do some animations and probably name them and have some fun. Our community will name them. Who knows? And then here's a proximity Trinky because it's a bat, kind of.
Yeah.
Gives like echolocation sort of. And then here's the rotary Trinky, kind of like an owl.
Yeah.
Like its head can move around. So this is just start. These are sketches, work in progress. And those are the Trinkies.
Yeah. So then I thought I'd show, do we have, how are we doing? Whoa, it's
yeah, keep going.
You want to quickly do a quick demo of a couple of these? So let's start with the slide Trinky. So the slide Trinky goes in this way. So this demo, the code I wrote, actually this is spitting out the slider data, and then on my computer, I have it hooked up to my my hue light here. So as I dim that bulb, so you can see the bulb got brighter and got dimmer. Kind of hard to maybe see the bulb itself.
Yeah, you can.
If I point it out. Hold on. Okay. So this is bright, and then this is dim. Yeah, you can kind of see it.
All right, do it again.
Dimming, brightening, dimming, brightening, dimming. So that's the slide Trinky project example. Okay, so that's slide Trinky. So I'm going to make this bright again. Thank you. And then rotary Trinky I thought would be... what's neat is actually for the Arduino HID, I found that there's this thing called surface dial. And this can mimic a surface dial. So when you press it and rotate it, it can actually perform things on Windows 10 as like a native device. So can you go to my computer real fast and I'll show. If you hold down the button, your Windows 10 pops up this thing. And for example, you can select volume, or you can select scroll or zoom. So let's do zoom. You select it by clicking again, and then you can use this to zoom in and, can you?
Yeah, I'm going to bounce between two.
Yeah. You can use this for zooming. And then if I click again and I select scroll, I can then use this to scroll as a scroll wheel. But it's the same rotary encoder. So they already kind of like figured out the UI for this. That's kind of neat. I thought this was a cool demo. So
Doom scroll and style.
Yeah, it's just scrolly. It's kind of a neat idea. So that's the rotary Trinky. And then the key Trinky, the neokey Trinky, we... hold on. Sorry. For the neokey Trinky, I actually wrote some quick code to turn it into a rubber ducky. So when you press the button, it opens up Notepad and types in "you've been hacked." So let's go to the computer and we'll see. We'll see if this works. Yeah, this extension cable is not very good. All right, so let's press this button. Weird. I don't know why this one's not acting so great. I don't know. This one's a little flaky. All right, so I'll demo this next time. I don't know why this neokey is acting weird. And then finally, proximity. which actually already did show off a little bit. Well, like nothing's working. Hold on. Okay, so this one, it's weirdly sensitive. I wonder if that's because there's so much more light here.
There's a lot of light.
So for this one, I turned it into like when there's a proximity. When the proximity of your hand is close enough to the sensor, it'll send a spacebar. So for this one, I made it so you can play the. Well, you can be very bad at playing the Dino game. Okay, so let's try again. Go, 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 go. Dino. Dino. Yeah,
All right.
so that's proximity.
Do it underneath here so I can also show this.
Okay.
You're going like that?
Yeah. But it's weirdly, it's very, I have to fix the sensitivity. Because I think I set the proximity before all these lights were on, and so now it's a little bit more sensitive.
Okay, cool. So I'm going to ask some more questions. Ready?
Yeah.
Slide Trinky could be a turtle with the neck sticking out. Yeah. Someone said they enjoy using the Neo Trinky. Seems like a cool way to add status lights to a small Raspberry Pi OT device. Cool way to take touch input to acknowledge events. Yep. Next up, someone said the bat looks like LaForge. Yes. I'm going to fly it over to Jeopardy. They better get LeVar Burton on there. Next up, was that an Arduino library to make the Windows think it was a Surface dial?
Yeah, that's the Arduino HID library. We don't have that support in CircuitPython for Surface Dial yet. Yeah, why is this thing weird?
Okay.
I don't like this extension cord. Let me get another extension
Someone
cord.
wants to... They want plastic enclosures for Trinkies. Yeah, I know on Pedro will probably make
You
those.
can totally 3D print plastic enclosures.
Okay, next up, as you do more devices where you can find... Do you know where to find compatible keycaps with traditional labeling? Delete, alt, etc.
Any MX key will do the job.
Okay, do you have one favorite besides Cherry MX that...
KL switches are pretty good, but like really anything that's MX compatible.
Okay.
This is really flaking. Oh, there you go.
Cool.
I mean that.
All right.
Okay.
There's a vote for a Trinky form factor with Wi-Fi BLE. That way you can power it within a USB port, and new power strip that has a couple USB ports. Good idea.
That's kind of like an ESP32 S2 feather though. Like I don't. It would be like so big. I mean. This is for like it's connected to a computer. Like these are not designed to be powered from a USB port. It doesn't make sense. The whole point is that you're sending data to a computer, and then the computer can act on it.
Yeah, we'll probably do a little, like power adapter specific pluggable Wi-Fi thing at some point. It might not be the same. It might not be Trinky. It might be something a little bit different. Next up.
Yeah.
Could one make some sort of stream control setup with different Trinkies doing different things? Yes.
You could. At some point, you would make like a custom build project. This is for like, there's times where it's like you just want one key or you just want one rotary encoder.
Okay.
And instead of having to like get an Arduino and plug this in and solder or whatever, it's all in one and you sort of like plug and go.
All right. And you mentioned that there's WASD keyboards that does caps, custom, etc.
Absolutely. There's keycap companies. Anyway, so when I use the Kano extension cord, which seems to be these 3 meter cords.
Are you gonna make a joystick Trinky?
I don't know. I mean, the thing is that's tough about a joystick is that there's a lot of torque on it. A lot of these things, I'm trying to pick things that don't have high torque because you'll just yank it out of the port, or you'll bang the port back and forth. So joysticks are like that. Joysticks are not sensitive. They're very abused. Compared to rotary encoders, you just can't. You don't have torque on the rotary encoder. You're twisting it.
Scroll wheel, the track balls. There's a couple things that we might experiment with, but stay tuned.
Yeah.
Okay. What else?
So next up, hold on. This key is definitely being naughty. I gotta figure out why this one's a little flaky. Okay, so that was my little ducky demo, and so then I was thinking of making. You were like, oh, well, how about we make like this kind of Trinky and that kind of Trinky? Oh, let's go to the computer. Like all these different kinds of Trinkies. I was like, well, I don't want to make like every I don't want to make like 300 Trinkies, like one for every sensor. So we thought, like, let's make, you know, a Trinky, like something that plugs right into a USB port that has a STEMMA QT connector, and then, you know, you can add any of our STEMMA QT boards on top. You just attach it on top, and then you can have, you know, you were saying like, oh, let's make, you know, one with pressure sensor or barometric or, you know, light or whatever, or, you know, gas sensor. And I was like, yeah, I think if you're going to do that, you would just plug it in over STEMMA QT and then you could run whatever. But you can't do that with a SAMD21. The SAMD21 just doesn't have enough memory to guarantee run every sensor that we have over I2C well, because it just has a limited RAM. And like if you start to do some of our more advanced sensors, or you start to like you try to do a little bit too much, and it quickly can run out of RAM. And so I thought, like, also for like displays and stuff, like you can't really run one of our OLED displays very well on the SAMD21. You kind of can, but like not that well. So I thought this would be a good opportunity to make some chips using the RP2040 instead of the SAMD21, which is not as compact. Like it wouldn't work on the Rotary Trinky because it really needs to be small, and the 2040 needs too much stuff. But if you're gonna, you know, if you have a little bit more space, the price is comparable, right, for the RP2040 plus all the extras. So, you know, I kind of came up with this on the afternoon, which is an RP, let's see, turn on T.U. So this is a RP2040 with a STEMMA QT port on the end, and it plugs into USB. And then this is the same size as our standard STEMMA QT, like 1 inch by 0.7 inch. So you could just like pop the sensor on top, and then you would like attach it somehow, like using the 4 mounting holes. And you would, you know, no, it doesn't make sense for every device, but like let's say you wanted a, you know, gas sensor. You would take an SGP40, plug this in, and then you could get data out. For a lot of people, I would recommend using something like the MCP2221, which would actually convert it to something that Python can read. But I can see some situations where folks are like, no, I really want it to spit out serial data, or like that JSON data, or they just, you know, they want it to come in directly into something like processing or Unity, right, where you don't have you don't want to have a Python interpreter feeding data into it. You just want it to read. You can open up a serial port and read the data, but anything where you call a Python interpreter from it gets complicated. And I get that. It's like there's people who they want to, you know, integrate it into some C code, or they want to maybe integrate it with web serial Java, right? All these things. It would not work well to do it over over Python, CPython running on the computer. So this would be, you know, a CircuitPython, or now even Arduino supporting board, and it just has a QT on the end. And it's really simple. It has like 2 megabytes of flash because you don't need that much. And then the boot and reset buttons are on the outside, so you can kind of squeeze it if you need to, because it's going to have the sensor on top. So
okay.
Question?
When do you think boards to convert a rotary encoder to I2C is coming?
I don't give ETAs.
Okay. I think someone's asking, is that a QT Py? No, it looks like it, but it's not.
It's not a QT Py, but I took a QT Py and I kind of tore it apart. Okay. It's single-sided, which will make it a lot easier to fabricate, and it uses a 603s, which I really like, instead of a 402. So it's a single-sided.
Suggestion, maybe question. Ooh, you could do a Trinky with male SH connector and a little bit of spacing, which you could plug most of the STEMMA QT boards in.
There's no such thing as a male SH connector.
Okay, there's no such thing.
That's right.
Yeah.
So you use this in a cable, because you'd have to plug it into the top. You'd have to plug it into the top anyways.
Okay.
Okay, so let me show. Let's show what I want, and then we'll go into the great search. Okay, so let's go. So this is my mimic, right? This is not the board I just designed, but this is like what, you know, it's similar to size. So the idea is that I would have a, you know, if you have like this VCNL 4040. Actually, I wanted my MCP 2221, and I forgot to grab it. Hold on. Sorry. There's so much on my desk.
All right. While you're doing this, I'm going to ask a question at the
Yeah,
same time.
ask a question.
What do you think?
Oh, here's.
What do you think the most elegant way to parse JSON serial data on a microcontroller is?
On Arduino, use Arduino JSON, and on something with CircuitPython, you can just use a string parsing capability or a val. It's a dictionary. Okay.
I'm going to vote for CircuitPython only because I've done a bunch of JSON parsing CircuitPython.
Yeah, you can see the TV Begon project. I don't have a JSON parser that'll fit in a SAMD21, so it val the file that contains the JSON, and it's fine. Like, you can do that. Like, nobody's going to root your chip, so who cares? Because it's like you wrote the code. So this is the MCP2221, which is that same, like, you could theoretically do this. You would have a board on top, right, and you could attach it and then have a little connector. And honestly, the MCP221 is popular. I think it could be more popular. I think it does solve a lot of problems because we have all this Python code. So, maybe I'd make a QT version of that, just, a Trinkey version of that as well. But this is, it's inexpensive. And then, this could mount on top because it's the same size. So the question is, how do you mount these boards on top? And then you could use this little cable to connect them. Because again, there is no direct pluggy. There's no such thing. Everyone's always like, oh, have a little. It doesn't exist. Believe me, if it existed, I would absolutely buy it. It does not exist. So instead, you have to use a little cable. And then, you could use something like these standoffs, right, to connect between the boards like that. I'd want a shorter one. And then you'd snap it together, and then this would be one physical shape. So that's what we're doing on the Great Search. I want to find these because I actually got these in a kit, and I don't know what they are.
All right, we're going to do the Great Search in a sec. Would you... I have ideas on how we're going to do some of these requests, but would you do a Trinkey with an NFC reader?
No, because the antenna would be huge. You'd bump into it, and you'd probably break your USB port.
Okay, so let's hop on to the Great Search. Ready?
Okay.
Where in the world is that part I need? The Great Search with Digi-Key.
The Great Search is brought to you by Digi-Key and Adafruit. Every single week, Ladyada uses her powers of engineering to find things on the Digi-Key site, so you can find things on the Digi-Key site. So let us know when you find things, or you can't find things.
Oh, you can't find things.
Well, a lot of people say, I finally found the stuff I was looking for. Now I can go to production, or now I can go to manufacturing, because before I couldn't figure out all the parts, lead times, all the things that I needed to get done for this giant project. So, Ladyada, what is this week's Great Search?
Okay, for this week's Great Search, let's go to the overhead. I want to find something that will let me take a board like this, which has 4 mounting holes in the corner, and then I have a separate board, and they're going to be connected together through this cable. Ta-da, like so. And then I want them to, instead of this kind of jangling off here, I want this to be able to mechanically be stable, connected here. And so on the version I have with the USB port, this plugs in, and I can even get even shorter cables, right? I can get a cable that's like, less than half a centimeter long. This would plug in together, and it would be one physical shape. So this is, I actually got these from a kit. Maybe it was a Pymaroni kit, I don't remember. And these snap into here. Oh, and they don't come in easily. This might actually be the wrong size. Hold on, let me get the my pliers, and we'll see. If not, I'll find the ones that are the right size for sure. So let's see, does this fit? Probably should have tried this before the video, but there you go. Okay, so this is one, and let's do the other one. So you definitely, these are a little tougher to do, but they do fit in. And then this also fits in. Also quite challenging. So maybe I'll get ones that are a little easier to fit in. Hold on, I'll do one at a time. Okay, so there's one. And then the other. Okay, so it looks like squeezing it is the best way to do it. But this is, mechanically a strong way to hold these. And of course, I only have 2, but I would have all 4. And then this would be like a very strong mechanical connection. I also want them to be shorter. Like these ones that I have in my tool bin, they're quite long. I think these are like a 1/4 inch or so. Let's see. These are, well, they're quite long. So they're 0.32 inches. So I want something that's more like, like a 1/4 inch would be plenty. So that would be that far.
So you came up with this, you're thinking about it, and then.
But what are these?
And you're gonna do exactly what you would normally do. We happen to like broadcast this and work with Digi-Key on these. So now you're gonna find.
I'm gonna find them.
these.
Okay, so now I've shown what I'm looking for, right?
Okay.
And here's the thing. I thought that these were called board standoffs, but they're like actually not called board standoffs. So this is the thing. Knowing the name of the thing is part of the hardest part of the search. So let's go to the Digi-Key site. Okay, so we're gonna do a search. So I actually originally looked for PCB standoffs. So it's like, oh, this is a nylon PCB standoff, right? So there's almost like nothing that came up, and there was like LED spacer standoffs, internal blocks. I was like, okay, well that's not the thing. So then I thought like maybe it's under standoff, and it turns out that you can go to board spacers standoffs. But when I looked here, I found like a lot of like screws and, hex thingies and like a lot of hex standoffs. And so I was like, well, let's look for active, and they're not threaded, right? Because they have the little thing. So I was like, well, it's not threaded. So I searched for this. So I spent a lot of time here, but all I could find was like these hex things. And like technically those are hex. And I was like, well, what's the screw size? I was like, well, it's kind of like a number 2, maybe. So I searched and searched and searched, but I was a little bit like, what are these? I couldn't find them because it turns out that these things are not, even though they are standoffs, they're not called standoffs. They're called PCB spacers. Different things. So. Sorry, they're not called PCB spacers. They're called board supports, PCB supports. So it's a different thing. So if you go to board supports, you're like, that looks like the right thing. So even though they perform the same purpose as a standoff or spacer, they're called supports. So this was kind of what I learned. So it's like, oh yeah, look, that's a thing. It's like, this is what I want. So let's find the exact one I'm looking for. So let's look for active and in stock. And then there's a couple different, there's a lot of options, but I think the most important thing is the board hole diameter, right? Because you saw, like, you have to really, like, fit it in. So let's make sure that we have one that's really, our holes are, if you look at the PCB, this is 2.5 millimeter, which is, 0.1 inch. So I'm going to basically select all 4 of these options, or all 3 of these options. You definitely don't want to go to 2, too small, and you don't want to go to 3, too large. Okay, so yeah, like these are looking good. Yeah, that's what I want. Okay, so then it's like, well, how tall do we want it between board height? And remember I said I want it to be higher than the USB-C port, for example. So, if you measure the USB-C port, it's like, 0.125, an eighth, sorry, not a quarter inch, an eighth of an inch. But maybe I'd be willing to go up to a quarter. In case like one size is much more common or much more available. So let's look, and then there's, we've basically like pared it down. So there's like now, okay, there's like these adhesives, which are kind of cool, but this isn't what we want. So I'm going to get the snap lock non-adhesive type. And then it's mostly a matter of like, okay, well, let's look at all the ones. So this one is kind of the closest to what I've got here. And it's also, what I like about all of these is that there's tons in stock. So it looks like Essentra makes some, and Keystone makes some, which is cool. And they're not too expensive. Worth makes them as well. But I like that this one, Keystone, like I've heard of them, looks like they have a lot of options. They have one in the 1/8 inch. So let's look for 1/8 inch. Or maybe like a little bit more. 3.5 millimeters. Yeah, I mean, there are not a lot of options for this. So of all of these, the Keystone has a low price and has the most in stock. So what I did is, first off, you can check out this cool 360. Always like the 360. You can zoom in. You can like rotate. Rotate. And then I looked at the data sheet, which I downloaded, and whenever I find a part that I like, especially a mechanical one, I look at the data sheet to see the catalog options because there's sometimes more info. Like for example, there's tension fit, easy lock in, and lock in, and like I was like, well, this is the easy version, so it doesn't get any easier than this. These look like much harder to fit, perhaps. But these are pretty easy, I guess. And then, yeah, they come in different lengths. But they also have a tension fit. I guess I might get a couple of each one of these to try them out. So it looks like one is permanent and one is tension fit. And this is permanent. So this one might be interesting because with this tension fit, I could tell people like, attach the permanent side to the Stemma QT board, sorry, to the Trinkey, and then the tension fit part goes above to the QT board. So I think I like 7789. Sorry, it's 8879 and 8888. So I think I'm going to get both of those. So this one, and then Keystone. Also, these are called board supports. So these. So I think I'll pick up, I'll pick up like 20 of each. And then I'll try them out and, I'll see which is physically feels easiest to use. Because with these, like, you really have to try them out, as you saw. Like this one's can be a little tough to use. Hopefully the tension fit ones are perhaps a little bit easier. But I think this is a good solution. This will let people mechanically attach boards on top without any soldering at all. And, I can include a bag of 10 with each kit, and then, you can make your own custom Trinkey, basically. So it's custom Trinkey land. And that's the great search.
Where in the world is that part I need? The great search with Digi-Key.
Okay, so let's do another question.
Okay.
Folks want to know about the calipers. We have them on our website.
These
Just
are
go to adafruit.com
yeah.
and just type calipers.
Calipers. Or you can get Mitsutoyu's, which I've had for a while.
Not an important question, but if you're looking for one, the NRF 52840 Feather Express has the space in the center as a debug port. The Sense uses it for sensors, which is great, but adds cost. Any chance to update the Express or another version replaces the debug with a Stemma QT?
No plans right now. I don't know if, maybe.
Got it.
I don't know. I got a lot of stuff on my plate.
All right.
I added to the long list.
Tricky naming. Thanks for the secrets. Are there any stackable supports? Make it like 3 high.
For those, I would use hex. They're called like male-female standoffs, and then you can have them stack up on top of each other.
Trinkey tower.
You can make a Trinkey tower.
Someone will make a Trinkey tower.
And you can use this in this board. You can get hex standoffs that will fit. The problem is that you need hex nuts and screws. What I like about these is they're all in ones, right? You just snap them on, and it's like, ooh, I got the mechanical connection. You don't need anything else.
Yeah. And then as we work on these, so these are, just 3 of the 5 that we're kicking off Trinkeys with. One thing that we've noticed is there might be like some really unique, interesting, weird, and maybe discontinued or not long life parts as far as like manufacturers making them. Might do some limited runs of not forever Trinkeys, also called NFTs. And we might have, hey, there's only 200 of these. And it's like some weird like Sony scroll wheel that was inside cameras, and we got a lot of 200 of them, and they're limited edition, not forever Trinkeys. So we might do something like that.
Okay. All right. Well, it's been a long 1-hour show, so we got lots of content. Thanks everybody for coming by. I think we
did it.
Blasted them with Trinkeys, with Bundleflies. Go try out the Bundlefly.
Yeah. All right. See you next week.
Slurp, slurp.